Well, welcome to our first video on lesson 2 of chapter 1. We're going to get into a little bit about segments and how we measure them, how we kind of think through that whole process. I want to start off just by thinking about some learning targets. We've already talked about a lot of other ones earlier in this lesson or in this unit. Just 3 today. We're going to talk a little bit more about what a postulate is. We're going to talk about a couple specific types called the ruler postulate and the segment addition postulate. We're going to focus on that 9th one mainly in this video. So as we start by thinking about what a postulate is, I'm just going to refer back to the notes we took earlier, the ones that look like this, and I'm going to look at the triangle that's on the back. We're just going to kind of keep this real simple. We might talk about this more in class. But we just went over a lesson that talked about undefined terms and defined terms. And that's just a matter of how do we communicate the objects that we're talking about. Okay, and then as we maybe look in life and we notice some patterns that happen in our world, sometimes we just say we're going to assume that this will always work. And that's kind of what we're doing with a postulate. So the 2 things that we're talking about in this lesson, we're saying we're making this rule. We're assuming that it's true. Then there will be times in class where we look at something called theorems, and it's still a pattern that we notice, but now it's going to be something that we explain why it works. So that's kind of that first learning target. It's just knowing the difference between those definitions, the postulates, and the theorems, and we're going to get into that a lot more in class as well. Okay, so back to our notes. Okay, we have something called a ruler postulate. Okay, it says the points on a line can be matched 1-to-1 with real numbers. The real numbers that correspond to a point is the coordinate or the location of the point. So when we think of a ruler, any sort of ruler that we typically have, it's pretty easy for us to say, well, at this location we're going to assign 4, and at this location it's 7. And then we can also be really detailed in the middle. And that's all this is saying. Okay, when we talk about a distance, okay, we write it just like this. Distance between A and B, we just say something like this. So it's really familiar or really similar to what we did with lines and segments and rays. But when there's no notation on the top, then we're saying we're going to come up with the distance. And we might say, that distance, it's 12, and maybe the units we're using were inches, something like that. Okay, we have a distance formula. When we're just thinking one dimension on a number line, then it's pretty simple. We just subtract one from the other. The technical definition is we think of absolute value of the difference between those coordinates. I want to explain a little bit what that means. So if we look at this example and they're saying find TV, that's the distance from point T to point V. And we can see that we have put it on a number line. We know that one of them is at 8, the other one's at 14. And typically to find that distance, we would just say TV equals 14 minus 8. And we would get 6. And that's totally fine if that's how you do it. Based on this definition, technically we could say, well, let's put absolute value around that. Remember that absolute value, once you simplify it, so we got that 6 in there, then whatever's inside as that answer we make positive, and we still get that answer of 6. Okay? What's nice about that is if you choose to use that absolute value, well, then if you look at your number line and you say, I don't want to go 14 minus the 8, I want to go 8 minus the 14. Well, that gets me a negative number. That gets me negative 6, but distance should always be positive. So in the end, I get positive 6. Either way, we get the same answer. This is probably a little bit more technical than what we really need to worry about, and I would still kind of consider just always going the bigger number minus the smaller number. Okay, one more example that we'll look at for this. These were our answers here. Okay, if we're going to find the distance from S to U, the little wrinkle here is S is actually a negative number. But the shortcut, the easier way to do that is to start with the one that's bigger. So start with the 10. And then we're going to subtract the other coordinate because it's a difference according to the definition. Okay, we're going to subtract a negative 4. You really should be saying this is SU equals this. Okay, so we're going to subtract that negative number. When I subtract a negative number, it really is addition. So I have 10 plus 4 gets me 14. Okay, so always take the big number, subtract the small number. You don't have to go through and do absolute value like this. Like that was just to kind of connect to the definition, but If you go the big number minus the small number, that will always work. Okay, just another example of that. In example 2, if one end of a board that is being measured lines up with 18 inches and the other one ends up at the 84-inch mark, how long is the board? Okay, and that's something that we could kind of mimic with our ruler as well. They're basically saying we're not starting at 0 way on this left side, kind of a glare there, but we're not starting way over here. We have a point that kind of starts at 3 inches, and it's going to end at 8 inches, and well, we know that that's a total length of 5 inches. We're doing the same thing here. So for this one, all I really need to do is go 84 minus 18. Just take those two coordinates, subtract one from the other, and technically take the big one, subtract the small one. That's kind of our working definition there. If I did that, I think I would get 66, and this is an application problem, so we'll say inches. Okay. Then our last one, again, there's lots of ways that we could look at a problem like this. I'm going to try to do it the more logical way, the way we probably would in real life. But there's a way of applying our math definition to it as well. We might talk about that in class a little bit more. So it says, on your trip to Detroit, you see that there's a rest area 17 miles ahead. You're at mile marker 93. What mile marker or markers might you look for to find that rest area? So we're just going to pretend that we're looking at a map, and here's our road. Okay, we're currently right here at mile marker 93. And we'll just say, oh, maybe this is like mile marker 150, and over here is mile marker 50. We're not seeing the other ends on either side. But this is kind of saying, you know what, we're going to go 17 miles in this direction. Okay, and what would this mile marker be right there? So in this sense, we'd be getting bigger, and we'd be saying, well, I need to add 17 to that number. So in this case, we'd say, let's go 93 plus 17, and that's going to get me 110. That could be one answer. But if you've been doing some driving on the freeway, or you watch your parents drive, well, sometimes you're heading in the opposite direction, and we're actually going to end up over here. Okay, and this is also going to be 17 miles, and we want to figure out what this one would be. And so now the numbers are getting smaller. So for this one, I'd want to go 93 minus 17 and get my answer there. Okay, so if I do that, I'm kind of doing this in my head here, so you can double check here, but I think we'd get 76. So I think we would have these two answers, and it's all about our perspective. Are we driving towards bigger numbers, or are we driving towards smaller numbers? And then we make the change accordingly. To me, this is how I would solve something like this, but in class, there is a way for us to kind of connect it to what we're doing up here with what the distance is. It's the absolute value of the difference. We'll try to cover that in class. So I'm going to end this video right here. This was on what is a postulate, and then what specifically is the ruler postulate. How do we measure some of those distances? And then our next little chunk in this lesson, we'll talk about what we call the segment addition postulate.